This is a quick tutorial and review of derivatives. So if we make an ax where x is the independent variable and y is the dependent variable, we can draw a line. And we should know there's a familiar equation for it, y equals mx plus b, where b is the intercept and m is the slope. And m being the slope, we can define how to calculate it as looking at the rise, which in this case is delta y, over the run, delta x. So m equals delta x over delta y. So that's the slope. It is also the derivative. The way we would write this is dy over dx equal, in this case, m. So that's the derivative, and that's the notation that we use. Oftentimes, we don't have x as an independent variable. We have something like t for time. And so I can write all these x's and replace them with t's. Everything's still the same. And in this case, that dy dt, if y is position, then dy dt actually has the meaning of velocity. If we extend this graph farther, we can have a more complicated function. And for that function, this simple line equation isn't going to work anymore. So I added two extra parts to this function. One where the slope is 0. So here, if we still had m equals 0 there, and then here where m is less than 0. And in this first part, slope was positive. It was greater than 0. So this is still a function. At any place, we can evaluate delta y over delta t to get the slope. And in the same situation, we can get a derivative everywhere. And it's going to change from place to place. We could overplot that derivative by making a new axis here. And for the first part, the derivative is some positive value, but it's constant. We'll just draw it here. For the second part, 0. And then for that last short part, it's negative, and it looks like it's about that. And so this blue curve is the derivative that we're plotting. And you can see how it goes from positive to 0 to negative. So it can vary with time too. I hope that helps your math.